Hi, my name is Mark Hopkins, and I work for the STM32 channel marketing team at STMicroelectronics. This talk is about the growing number of expansion hardware and software solutions that we now offer the STM32 micro developer community. Application complexity and code size keep increasing as electronic products are made smarter, interactive, connected, safer, and more secure. Software engineering now accounts on average for more than 60% of development project cost. However, ST and ST partners offer STM32 hardware building blocks with pre-integrated embedded software packages that already implement these expanding system capabilities. Each package is a ready-to-use project, pre-configured to compile and run out of the box on STM32 add-on hardware. These STM32 expansion solutions accelerate system-level prototyping so that developers can focus more of their attention on coding applications. I'm going to start this talk by giving you a brief overview of our successful STM32 micro portfolio in ecosystems with user-friendly tools. Then I'll discuss the STM32 expansion hardware and embedded software solutions that I've just mentioned, and I'll provide some application examples. Our STM32 portfolio includes MCUs and MPUs that are based on one or more 32-bit ARM RISC core. We launched the first ARM-based MCU family way back in 2007, and it is still fully supported today. Since then, we've added 17 more families with new features and capabilities to meet customers' expanding application requirements. Today, our portfolio includes 1,600 part numbers, with more pin-to-pin compatible ARM Cortex-M and ARM Cortex-A7 based micros than anyone else in the world. This slide shows our STM32 portfolio by product category on the left and by ARM core type along the bottom. Starting at the top is our MPU category with the STM32 MP1 family, followed by our 4 MCU categories: high performance, mainstream, ultra-low power, and wireless microcontrollers. Notice that the performance of each series is indicated by a CoreMark benchmark score. Each STM32 family includes extended industrial temperature versions, and each part is backed by a rolling 10-year longevity support guarantee that automatically renews on the 1st of every year. To find out more, please visit us at st.com/STM32. A big reason for the success of STM32 microcontrollers is the extensive ecosystem that we've built around them with the help of our technology partners. This includes a wide range of evaluation boards. These boards include the STM32 Nucleo boards, shown on the far left, which are USB-powered and provide an integrated debugger and programmer and comprehensive libraries along with example software at prices starting around $10. The STM32 Discovery boards and the evaluation boards offer additional prototyping capabilities and functionality at slightly higher but still very affordable price points. The next ecosystem offering is our user-friendly software tools for Linux, Windows, and Mac-based machines. Our STM32 toolset includes the STM32Cube MX, which provides an intuitive user interface, along with graphical wizards that enable visual pin and I/O selection and clock tree setup and peripheral configuration without having to know the actual register settings. Power consumption is calculated for user-defined application sequences, and the initialization C code can be generated for a wide variety of free and commercial IDEs, including our own STM32 Cube IDE, IAR, and ARM's Kyle. The STM32 Cube programmer is used to flash on-chip memory using a wide variety of the STM32 interfaces. And we provide real-time monitors for fine-tuning STM32 high-speed communication, power consumption, and RF propagation. The next ecosystem benefit is our extensive embedded software, often called firmware or middleware, that we provide for each micro series, and that we now also publish on GitHub. This embedded software includes drivers, API sets, real-time operating systems, communication stacks, and embedded bricks for our various MCU and MPU series and ecosystems. But our main focus today is the STM32 expansion solutions that are represented by our last outer ring of this ecosystem wheel. These expansion solutions include ST add-on hardware and corresponding expansion software packages for implementing the key functions of modern embedded systems such as power management, wireless data acquisition, wireless connectivity, physical and cybersecurity, graphical user interfaces, AI vision and speech recognition, motor control, motion and gesture recognition, acoustic cancellation, cloud integration, and many more. These packages are ready-to-use projects from ST and ST partners that can be exploited to rapidly demonstrate and prototype new designs. This slide summarizes the STM32Cube ecosystem for real-time embedded application development with ARM Cortex-M. Our software tools are shown on the left, and our embedded software is shown on the right. This ecosystem can be downloaded free of charge at st.com/STM32Cube. The ecosystem for STM32 MP1 microprocessors is based on the OpenSTLinux distribution that runs on ARM Cortex-A7. In fact, we fully integrated the STM32Cube with OpenSTLinux as a single design suite to support the Cortex-A7 plus Cortex-M unified architecture of our MP1 line. In fact, STM32Cube developers can now easily migrate existing Cortex-M4 code bases over to MP1 processors. OpenSTLinux is an ST mainlined open-sourced Linux distribution. ST upstreams the entire code to the community and keeps working through consortiums like Linaro and Yocto to ensure global compatibility. ST maintains board support packages for 2 years of kernel releases, including new feature adoption and corrective support the first year, then continued corrective support the second year. The best source for OpenSTLinux information is the ST Wiki provided below. Here is a summary of the very affordable STM32 Nucleo boards that come in 3 form factors and provide various kinds of connectors for easy STM32 hardware expansion. These boards work seamlessly with a wide variety of open and commercial IDEs, and they can also be found on the Mbed and Arduino websites. Let's now look at STM32 expansion hardware for implementing special embedded application functions. ST has created an open development environment for fast and affordable IoT project development. This environment starts with X-Nucleo modules, used to expand the capabilities of Nucleo development boards for specific application functions. These add-on modules are provided by ST and ST partners and often include STM companion ICs for sensing, power management, motor control, audio applications, and wireless connectivity. Roughly 60 X-Nucleo modules are available from ST today, and the portfolio is rapidly expanding to incorporate new technologies and protocols. Here is an X-Nucleo long-range asset tracking module with a sub-gigahertz Sigfox radio. Other X-Nucleo modules support wireless communication protocols such as 6LoWPAN, LoRa, near-field communication, Bluetooth 5.0, Bluetooth Mesh, and Zigbee Mesh. UWB and narrowband IoT expansions can be expected from ST next year. This is another X-Nucleo module example. It provides an SPI LCD display for rapid GUI development and prototyping. It uses an X-Nucleo Touch GFX software package that I'll be explaining in a few slides. Let's now look at the pre-integrated STM32Cube expansion software packages for implementing the X-Nucleo application features. Each expansion package is a ready-to-use project that is pre-configured to compile with multiple IDEs and run out of the box on a target X-Nucleo board. These packages include low-level drivers, middleware libraries, and sample application codes. Notice that X-Cube packages come from ST, while iCube packages are coming from ST authorized partners. This X and I distinction is also used for OpenSTLinux expansion packages as well. Besides the X-Cube packages for single specific functions, there are also STM32 functional packs that combine X-Cube packages and their associated X-Nucleo hardware as ready-made platforms for application prototyping. Many X-Cube and iCube expansion packages can be found at st.com, but I'm only going to show these categories and highlight a few examples. These are examples of OpenSTLinux expansion packages that run on the ARM Cortex-A7 side of STM32MP1 microprocessors. They are mainlined by ST, and they're available at st.com, wiki.st.com, and on GitHub. XLinux AWS is a cloud connector package that connects MP1s via Wi-Fi as end devices to Amazon Cloud Services. XLinux AI is an AI package for computer vision that includes image classification examples based on TensorFlow Lite models and object detection examples based on Coco SSD MobileNet V1 model. XLinux Premint is a predictive maintenance application that implements the edge gateway function between wire-connected sensor nodes and cloud services. ST has opened the STM32Cube MX to iCube packages from ST partners. The same plugin support for X-Cube expansions is now available for iCube package integration. We provide the STM32 Pack Creator, which is an STM32Cube MX utility that facilitates package creation, along with guidelines to ensure uniformity and full compatibility. Here are some iCube examples. iCube LRWAN is a 900 MHz LoRaWAN communication application from USI. iCube NetX is an industrial Ethernet protocol application from Hilscher. And iCube EMBOS is a real-time operating system expansion package that guarantees 100% deterministic real-time operation. The Touch GFX expansion package is a free GUI development tool. It enables the rapid creation, simulation, and prototyping of GUIs with STM32 hardware, like the X-Nucleo display module previously shown. The suite includes a designer tool, which is a drag-and-drop GUI builder, an engine consisting of STM32 graphics libraries, and an IDE project generator, which generates the C++ code. The tool suite runs on a PC, and the applications run on bare metal or any RTOS. Here are some of the X-Cube expansion packages for motor control that can be downloaded from st.com. ST also offers X-Cube connectors for connecting STM32 microcontrollers as end devices to service provider clouds, including Amazon AWS, Microsoft Azure, IBM Watson, and Google Cloud. Ready-to-run firmware examples using Wi-Fi and Ethernet connectivity are provided for quick evaluation and development with STM32 boards. My last example is the X-Cube AI expansion package, which automatically generates and integrates pre-trained neural networks into an STM32 user project. The tool provides native support for many deep learning frameworks, such as Keras, TensorFlow Lite, Caffe, Lasagna, and any others that export the ONNX standard format. This package also enables neural network model validation on the PC or on the micro itself, and it provides STM32 performance measurements. ST produces many types of valuable content about its products and targeted applications. st.com/STM32 is the first place to go for STM32 MCU and MPU product information, collateral, videos, and links to other resources. The STMCU Finder is an easy-to-install, simple-to-use application for Windows, Linux, and Mac devices. This application provides multiple selectors to guide users to the right STM32 micros and boards according to their application requirements. The ST community is a great way to get involved by asking questions, sharing projects, and collaborating with global community members. Also check out the STM32 MOOCs, massive open online courses if you want to sharpen your skills and maximize the performance of your application. These courses are given by ST technology experts and are available online to take at your own pace and convenience. For technical information and questions, please check out the STM32 wikis, ST community blog, and our online technical support service. If you are interested in becoming an STM32 ecosystem partner, we invite you to visit our ST partner link below. In summary, the STM32Cube and OpenSTLinux ecosystems include valuable and integrated expansion packages for system-level prototyping. These middleware packages are ready-to-use projects from ST and ST partners that support specific X-Nucleo application functions. Their benefit to STM32 developers is fast project jumpstarts, quicker design validation, and earlier product realization. Please visit our ST Partner Hub to see STM32 demos and post any questions. And thank you very much for your STM32 interest.